Hello and welcome to the channel Understanding.Concepts.Of.Physics. Today is going to be a slightly larger video. Just be with me for the entire video to understand this topic. This topic consists of two parts. Today what we are going to do is only the A part. B part will be doing separately in the next video. The topic's name is Graphical Representation of Linear Simple Harmonic Motion. So we are going to represent graphically the linear simple harmonic motion. Now the particle the video in which in this video what we are going to do is we are assuming that the particle is beginning from the mean position. So what if the particle begins from extreme position? This part will be taking it one of the another videos. So let's just start with mean position. So if we want to plot a graph, then we should have data, and for data we need an equation. Y is equal to, let's say, 4x plus 3 and such kind of equation. So with equation you get data, with data you can plot a graph. So I need an equation first. So I take an equation for displacement. X is equal to a sin omega t plus alpha. This is my general equation, and here I am since assuming that the particle is beginning from the mean position, the alpha ka value is 0 or pi. Now in this case I am assuming that a value of alpha is 0. So if I put a 0 over here, omega t plus 0 is omega t. So omega t comes here, omega t comes here. Otherwise, if you just do it separately for these two cases, then there will be total 4 cases. But we are going to do only 2. So alpha is equal to 0, we are going to do. So I got an equation of displacement x is equal to a sin omega t. And if I differentiate this, I'll get velocity. So if I differentiate dx by dt, this will be d by dt of a sin omega t. Now since a is a constant, a will be thrown outside, and derivative of sine is cos omega t. But the most important aspect is there is an omega t inside this. In derivative we call this as a chain rule. So a is thrown outside, derivative of sine is cos omega t, and there is one more omega t. So we'll have to keep that omega t separately. So this is cos omega t and derivative of omega t. Now derivative of omega t is omega. So that omega, if I am writing, I'll write it over here. So I get a cos omega t. That's it. So you remember derivative of omega t is omega. So that omega I am writing it over here. I'm sorry, I just wrote a cos omega t. So now it is a cos omega t, a omega cos omega t. So velocity is found out, displacement is found out. Now if I differentiate velocity, I'll get acceleration. So if I differentiate, a omega is a constant, so a omega constant outside, derivative of cos is minus sine, so I'll write minus over here, minus sine omega t, and derivative of omega t separately. Now derivative of omega t is omega, and applying over here, so omega into omega will become omega square. So my equation will turn out to be minus a omega square, 1 omega from previous and 1 omega from here, sine omega t. So I get minus a omega square cos sine omega t. Now I have got the equations. Now I'll try to find out the data. So for data I need some specific values for dependent and independent variables. So I am going to assume how to fill this time. If you see, t is in the first thing, then comes omega t. Now omega t, why is omega t? Because I am seeing that omega t is in each and every equation, all three equations. So I have made a column for that. In fact, this is also sometimes called as phase. This is time, this is displacement, and then we have velocity, and we have acceleration. So I have just acceleration, written all those stuffs what we are going to assume. Now time is something independent variable, so I'll just take the value of time as I want it. So if time is 0, if time is, let's say, 0 into omega would go to 0, so this is 0, and sine 0, we all know that sine 0 is 0, and if sine 0 is 0, 0 into a would be again 0, so I get x is equal to 0 when time is 0. So when time is 0, I can say that my displacement is also 0. However, first I will try to fill up with time. So I am going to assume that time is 0. So time is 0. Then I am going to assume that the time is equal to a very special time called as time period. So t is time period, and then half of that in the middle column, t by 2, and half of this value that is t by 2 ka half is t by 4, so that is over here. So you can see that we are just moving ahead t by 4 in each column. So this was 0 t by 4, this is 1 t by 4, this is 2 t by 4. So 2 t by 4 is nothing but 2 1 2 2, that is t by 2. So t by 4 is not 2 t by 4, and this is 3 t by 4, this is 5 t by 4 t by 4, and this is 5 t by 4. So I'll write with the pen. So this is 3 t by 4, this is 4 t by 4, which is actually 1, and this is 5 t by 4. So if you have got this is 0 t by 4, this is 1 t by 4, this is 2 t by 4, this is 3 t by 4, this is 4 t by 4, and this is 5 t by 4. So if you cancel it out, and you will get this equation. Now comes omega t. Now remember that omega is equal to 2 pi by t. Omega is equal to 2 pi by t. And we have omega t. So 2 pi by t into, now t ka value, small t ka value is 0. So 0 into anything comes out to be 0. So my first value goes to 0. Then comes omega t ka value equal to 2 pi by t. Omega value is 2 pi by t, and small t ka value is t by 4. So in place of small t, I'll put a t by 4 here. So my equation will turn out to be t by 4. Now if you check this equation, t and t gets cut. So you get 2 1s and 2 2s, and I get pi by 2. Pause the video in case if you are not able to follow it up. Pi by 2. So this is pi by 2. Then comes t by 2. So omega t ka value is 2 pi by t, and in place of this small t, t by 2. So in place of small t, t by 2. So I'll get t by 2. Now t gets cut, 2 and 2 gets cut, and you get pi. So I get a pi over here. Now if you can get the logic behind this, you do not have to solve it further. You are not supposed, you are not also not supposed to write all these things. You can just say 0, pi by 2, pi. So you can just get, this is 0 degree, this is 90 degree, this is 180 degrees. So this should be 270 degrees, 360 degrees, and 450 degrees, which in radians would look something like this: 0, pi by 2, pi, 3 pi by 2, and 2 pi, and 5 pi by 2. Now here again you can just offer it like this: 0 pi by 2, 1 pi by 2, 2 pi by 2, and 2 and 2 gets cut, you get pi, 3 pi by 2, then you have 4 pi by 2, and then you have 5 pi by 2. So you can just work around, and you can just get that value. So if you have followed this up till now, we are going pretty nicely. Just be with me, keep following the video. And now we go to displacement, that is x. So you have an equation of x. This is my equation of x, and we have the values of omega t's everywhere. So we'll keep on putting one by one. So when omega t ka value is 0, sine 0 is 0, and 0 into a is 0, so you get x is equal to 0. So you get a 0 over here. So I'll write a 0 over here. So I get a 0 over here. Then comes next value is omega t ka value is pi by 2. So pi by 2. So if I put a pi by 2 over here, I get sine pi by 2. Sine pi by 2 is sine 90, and sine 90 is equal to 1. So this value is 1. 1 into a is a. So my displacement ka value is a over here. So I'll write with a pen, this is a. Then comes omega t ka value as pi. If you can see here, omega t ka value is pi. So omega t value is pi. So if I put a pi over here, sine pi is again 0. 0 into a is 0. So you get again a 0 over here. I'll write with a pen. This is 0. Then comes next value is 3 pi by 2. So omega t ka value is 3 pi by 2. So if I put a 3 pi by 2, now sine 3 pi by 2, sine 3 pi by 2 is minus 1. So this value is minus 1. Minus 1 into a is minus a. So I get a displacement ka value as minus a. So I get a minus a. Now you can bring up the logic that 0, a, 0, minus a. If you see this 0, a, 0, minus a, now the next value has to go to 0. So my equation will turn out to be 0, and then it will come as a. because if you see there is a plus, then 0, then is a minus, then is a 0. So this is the way how we filled up the displacement ka column. Now we fill up for the velocities column. Let's see how it works. Now for velocity you will work on velocity, equation of velocity. So omega t, the omega t ka value is 0. So omega t is equal to 0. So 0 in cos 0. What is cos 0? Cos 0 is 1. 1 into a omega is a omega. So this comes out to be a omega. Now if this is a omega, my next value goes to 0, and a omega then goes to 0, and then it will be minus a omega, then it goes to 0, then it is omega, and then it is 0. But make sure that you at least find 2 to 3 values. So my v would stand as a omega. Why is it a omega? I just showed you. Okay, because omega t ka value is 0. 0 cos 0 is 1, and 1 into a omega is a omega. Again I can work for second value as well. So pi by 2, omega t is pi by 2. So if this is pi by 2, cos 90 is 1, cos 90 is 0, and 0 into anything is 0. So I get a 0 over here. So I'll just recreate this: 0, minus a omega, 0, a omega, and 0. Same way, if you fill up for acceleration, if you do that for acceleration, you use that equation for acceleration. Omega t value is 0, so I'll put a 0 over here. Sine 0 is 0, sine 0 is 0, and 0 into anything is 0. So I get a 0 over here. Then we come to next value for sine. So omega t value is pi by 2. So sine pi by 2 is 1. 1 into minus a omega square is minus a omega square. So I'll write with a pen minus a omega square. Then it comes to 0, then it is going to omega square, then it is 0, then it is minus omega square. But just a reminder, just a important note here, that never go for a direct filling by logic, because you never know the first or the second value is plus or minus. So always go for starting with 1 or 2 values by some equation, and then you can extrapolate that to further thing. I think so the video is going to be long today, so I'll halt at this point, and we'll continue this same topic in the next video. And you can just connect in a connectivity, you can watch the other video. The video which is following is the continuation of this. Thank you so much. Have a nice day. Watch the entire videos. Subscribe the channel in case you have not done so. I'll be drawing the graphs in the next video. Thank you so much. Have a nice day. Bye.